All right, so we're going to be focusing on the frame that the previous group showed and how it's changed from our previous design. So with our feedback from before, we decided to kind of shelve as much modularity and focus mostly on strength and how simple and cheap it is. So we've taken the galvanized perforated steel and just gone for some plain carbon steel tubes that are going to be welded together, as well as shrinking it to fit the jaws that the previous group showed. So it's going to be a 30 by 15 by 15 rectangular shape that's going to be all welded together. And if you were just to buy the galvanized steel that we were using before, it was about $82, whereas this, with being super cheap steel, is only like $10. And it's also incredibly light, being less than 8 pounds. And this system is not showing how the legs are going to connect to it. We're just going to use a very similar system to what we're currently doing, but that hasn't changed too much. Again, our revisions is mostly trading the adjustability for simplicity and durability, as was mentioned in our comments. And then we're welding the frame because the welding will be stronger than having bolts, which we have to worry about shear stresses. And then the strength is also going to not be as strong because with our simulations we found that it was just able to support pretty much anything we could throw at it. So we're focusing mostly on cost and weight to make it easier to potentially reproduce and fix. And then with the total weight going from 20 to 7.5, and also with the price being dramatically decreased.
So without too much information from the other team at this moment, we went through FEA and assumed two modes of force. One is torque on one direction, and one is the total load from all other components sitting on the top of the frame. And we found out the maximum shear force is 1/4 of what is the material can support. We shrink the size of the material from 1 3/4 of an inch side to 1 inch side. Still a square tube. And overall static factor of safety is over 4. I did several dynamic study as well, and then the result all returned about the same. So you can see the stress concentrations mostly the 4 top connections, and those are going to be welded. So the other parts where the jars and pole system will be connected to have a safe space for us to do further milling and then other modifications like drilling holes for bolts and maybe attaching other parts to house other components.
So this is our failure modes and effect analysis. This was one of the main things that drove us to do welds instead of connections. You can see how high this risk priority number is just because of the severity of the failure. If the bolts failed, everything could drop. You could possibly harm your limbs, or maybe the crusher would just break. So that was a big thing. The occurrence was pretty high as well because the strength of the bolts wouldn't be strong enough to hold all the torque that was being put into the system. And the tension for bolts also wouldn't be very high. I mean, it breaks and then you know it's broken. So this was way higher than all of our other risk priority numbers. Switch it. So after using welds, the severity is still pretty high, but the occurrence goes way down because welds are significantly stronger than bolts. Also, detection would go down as well, just because it's easier to detect if welds are breaking rather than bolts are breaking. So now this is in a good range with the other numbers. This is what we want to see. So now if we want to do more FMEA stuff, we can go on to the next failures, which is magnitudes lower than what it was before. And we've changed the design, so we may go back and test for other sorts of stresses or the power input from the power team.
All right, any questions?
So, 2 questions. One, since it's going to be significantly lighter, what type of theft detection are you guys going to implement with the frame? And then second, on your FEA studies, a lot of the forces were on the top. Are you planning to have both the crusher and the sorter to be on top of the frame, or are you guys going to try and see this somewhat inside of the frame?
So I'll take the first thing first. So we already talked about the theft protection. So the crusher team is doing a incredibly high density. So it's a large steel plate that is pretty thick and it's incredibly heavy. So basically what we've dealt with is it's super heavy already. So we're basically just trying to make it so we can incorporate their thing. As far as theft protection, we can swap in wheels or feet. They can be fastened to the ground, as well as weighed down and other sorts of things. And then for the where the thing's mounted is because it's got the box at the top and the bottom, it's actually going to be mounted inside the box. So then it can be mounted on top and bottom, which is going to lessen the strength, or it's going to lessen where the forces are concentrated. The study we did there, everything was putting on top versus being on the inside where it would be distributed more evenly.
I have more to go off that. So this beta design, the whole premise of this was make everything way lighter, make everything way cheaper, bring it down to the most simple design we can so it actually meets the requirements, and then build off from there. So like in that case, we could either put the sorting system below the frame, or we could extend the frame, which would increase the cost by a little bit. But since we've brought it down so much, then we have options to actually change our design from there.
And on the FEA stuff, so we basically assume the most extraneous situation, which is having everything on top of the frame rather than being distributed. So that would be our most unlikely case. Also, the force, the total downward force is corresponding to 250 kilograms. That would be about a good range for all the other components we weigh. And the torque is about 1,000 Newton meter. So that would also was considered a good range.
One comment, just so if you are welding all the frames, you need to make sure that the crusher can fit into your
Yeah, as they showed
frame.
in theirs, they had an image that had our previous design, which is using the same size. So the only difference between this and the one they showed where it was already inside it is the material. So everything we already know will fit inside this current design.
Okay.
Okay.
Thank you.
Thank you.